Thank you for joining the Change I Am Possible, which is India's first Future Tech Meets Sustainability podcast. And today I have with us Mr. Arun Kumar Pati, who's a professor in Quantum Information and Quantum Computation Group at the Harish Chandra Research Institute, Allahabad. Before joining the institute, he was a scientist at Theoretical Physics Division, BARC. His research areas include all aspects of quantum information and quantum computation. He has more than 150 research papers in international journals and conferences. He has edited 2 books, Quantum Information with Continuous Variables and Quantum Aspects of Life. He was ranked among the world's top 2% scientists by Stanford University. So, Professor, it's a complete pleasure and honor to have you on the show. So why don't we start with the double slit experiment and explaining to my audience or to me specifically what double slit experiment posits, because there is 2 branch of people, the one which says that particles have a duality in nature. They can be a particle as well as waves. So there's a certain group of people who believes in the duality nature, and there's a certain group of people who believe that a conscious observer creates reality. So it's a little mind-bending. Could you explain double slit experiment and what are your views on it?
Yeah, so before I tell a little bit about double slit experiment, let me tell you why I got excited about quantum mechanics.
Yes, that would be super awesome.
Before I thought of becoming a physicist or scientist, I had used to write a lot of poems and songs when I was in school and college, and then I thought maybe I will go in film line or maybe acting or maybe music director or maybe lyricist. I was having that kind of idea. But when I came to know about this basic quantum mechanics, especially this wave particle duality in BSc, I was really curious. How come single entity behave in both like wave and particle? That was the starting point and turning point. I thought, no, there is something wrong in quantum mechanics. I have to solve this, this wave particle duality paradox. That was the kind of motivation I got. And at that time in BSc, we had not serious full course on quantum mechanics. We had only very brief kind of few chapters. What is at that time you to call like modern physics. We didn't have quantum mechanics like now. What students learn in BSc or plus 3, we did not have that kind of full course. But whatever we had little bit, it was extending enough. So I thought, no, I will do only quantum mechanics. Even I was determined कि even if I don't get into research institute or if I don't select as a PhD student, if I get some odd job like bank or maybe in some other odd job, I will still do quantum mechanics. That was kind of motivation I had. So coming to this double slit experiment, this is the most beautiful and most fundamental experiment that you see when you learn the quantum mechanics, learn about quantum mechanics for the first time, because this setup tells you one of the key feature of quantum world that really demarcates from classical world. So in classical world, we see that any physical entity is always in a definite state. Okay, if you take a pen or your finger, it is always pointing this up, or my finger can point down. But when you go to quantum mechanics, what you see is that not only your object can remain in a definite state, but they can also remain in so-called superposition of 2 or more distinct physical states. That means if this is a quantum finger, at any given time, this can not only remain like this or this, but it can remain both this and this. So that is the bizarre thing that happens. And this wave particle duality is something you actually do, you test it using this double slit setup. So classically, if you imagine this experiment, what will happen? If you suppose you have 2 windows on a wall, okay, and you are throwing ball one by one, okay, and there is a screen, there is another wall behind this first wall, and if you throw your ball one by one, what will happen is if both the windows are open, you will see 2 humps on the wall which is behind this first wall. Okay, So if you close one of the window in first wall, you will see a single hump kind of thing, because all the ball that you're throwing, they will go and they will be accumulated, which is centered around just behind this first window. And similar will happen if you close this other window and do the same thing with the this other window open. But if you do this experiment with quantum mechanical particles like electron or photon or whatever, proton, whatever you can think of, you don't see some of these two humps. What you see is a strange interference kind of pattern, which you would see like with water wave or maybe sound wave, this kind of thing you see. And that you explain only by bringing this so-called quantum superposition. So what you say is, at a given point of time, throwing these particles one by one, it is not that one particle goes to one slit, another particle goes to another slit, and at the end, you build up this, you see the interference. No, it's not that. When you send a single particle, this particle somehow goes through both the hole, or both the slit, okay? So this is the key demarcation, a key feature that you see with quantum entities, which you don't see with classical entity. The classical entity will go or will pass through only one hole or one slit, whereas the quantum entity, it will pass through both the slit. If you don't say this, then you will not see the interference, because if you deny this statement, then it amounts to saying that you have put a detector somewhere on this slit or the hole, and you are recording through which slit this particle is going. So once you do that, this interference pattern will disappear. Okay, that means this single entity is actually going through both the slit. And actually people have done the experiment. So what people do is they have a source that it emits particle one by one, and they have a double slit setup, and they have a screen behind the slit, and they ensure that during the transit time from source to the screen, there is only one particle present throughout the setup. Okay? That kind of thing will have actually taken care into, and then they send particle one by one, they wait long enough, maybe 1 day, maybe 2 days, maybe few days, and at the end, they see the interference. So this is something really miraculous, really bizarre, and it happens. And we still don't know, even after 100 years of quantum mechanics, we still don't know why it happens, but it happens, That is the mystery of quantum mechanics. And this is the starting point of the whole, new quantum theory and everything. The whole field of quantum computing, quantum information, everything depends on this strange feature of quantum entity, that it can exist in superposition of both the possibilities.
You mentioned that you were a creative person. You wanted to do music, and when you kind of discovered the quantum mechanics and in this bizarre way it behaves, you got into quantum mechanics. And I guess creativity is linked to who's very curious and asking deeper questions, because I guess to get into quantum mechanics needs someone who's completely vested in the space, body, mind and soul, because I think quantum physics, quantum mechanics is so deep, because as soon as you get into it, it opens up these bizarre worlds, what's going on, right from your superposition to entanglement. There's some really, really crazy things happening. So yes, I think the more somehow I feel that if we kind of understand that, I think we'll understand everything about the universe, So there is this quantum physicist called Seth Lloyd. I'm sure you know about him. He's written a book called The Universe is a Quantum Computer. Would you like to talk a little bit about that, and what does he actually mean by that? Because my little basic understanding of what the universe is or how it functions is that, it's made out of atoms. And these atoms, when they come together, they clunk into being animate and inanimate things, right from the star, sun, moon, the air that we breathe, to the trees, to the diamond, to the coal, to us human beings. So what was Seth Lloyd trying to say when the universe is a quantum computer? Would you like to actually unpack that? Because Niels Bohr also had a statement: everything we call real is made out of things that cannot be regarded as real. So what is going on? What is reality? And could you, I mean, it's a little deep question, but would you like to address that?
So let me first answer the Seth Lloyd's contest question. So why he thinks that universe is a quantum computer is for the following reason. So you see, when you think of a computer, whether it is classical computer or quantum computer, essentially you have to encode your information in some physical system. Okay, this is the first point one have to appreciate. And why it is so? Because information is something abstract entity. Okay, so you have to encode the information in some physical degrees of freedom of a system. Okay, and that system can be classical, can be quantum. Okay, so if you encode your information in classical physical system, we know that we have to apply Newton's law or maybe Maxwell's equation and so on to describe the classical system. And when you do that, we say that you are doing classical computation. So classical computation is nothing but storing and processing information in physical system. Those obey classical laws of physics. And if you generalize this terminology to quantum domain, you can define what is a quantum computing. So quantum computing essentially is the way where you encode information in quantum systems and process information using quantum mechanical principles. Okay, so that is essentially, in short, what a quantum computation is doing. So you see, now one should take this view that information processing is not something abstract. It had to do with physical system and physical evolution that may be going on with a system. Ultimately, then you can do computation with any physical system, because any physical system is a legitimate system to be suited. You can use it to encode information, and as long as the system evolves in time, it has its own dynamics, you can process information. Okay, it may be complicated, may be difficult, may be inefficient, but in principle you can do it. So once you take this view and you apply it to the whole universe is also evolving. It has its own dynamics. So this is, in short, what Seth Lloyd tried to convey, that ultimately every physical system you can use to encode and process information. So universe is a physical system. You can use it to computation. It can be classical, it can be quantum. So if you view that universe needs quantum mechanics, or indeed it is the dynamics inherent are actually described by quantum mechanics, then you can say, okay, universe is also doing quantum computation. So that is essential philosophy he had in mind. So Niels Bohr was of the view that maybe you need a paradigm shift in the way you view your world. Okay, so we are all familiar with classical world, the world in which we live. Okay, and in the classical world, everything or whatever we see, we believe that they really exist. Okay, so what it means is the following. So let me tell you a very crude example. Okay, so for example, this color of my shirt is green. Okay, so this means this attribute has some element of reality. What it means? It means that whether I look at my shirt, or you look at my shirt, or somebody else look at my shirt, the color is going to be still same. Okay, it doesn't change irrespective of whether you look at or don't look at, and so on. Okay, that means this attribute of my shirt, which is the color, and this color is green, this attribute is an element of reality in classical world. But what happens is, when you go to quantum mechanics, unless you do a measurement and you have recorded the measurement outcome, the attribute may not exist. Okay, so that is the reason why Niels Bohr thought maybe the observer who is doing measurement, he or she creates the reality. Okay, so reality is not something exists independent of your observation. So he made this profound statement, which is true, and may not be very comfortable with this idea. Like, for example, Einstein, he never believed with the view of Niels Bohr. He was a person who believed that everything should be local and real, unlike classical world, which is not true. Now we know that quantum mechanics does not respect this kind of view. We know that. But at that time, it was a great, paradigm shift in the way we understand our world, the way we try to make connection to, classical worldview. So that is essentially the point what Niels Bohr was trying to figure out, trying to suggest at that time.
There's a certain camp like Elon Musk and Neil deGrasse Tyson, and there's Joshua Bach, who's an artificial intelligence general researcher. Then there's Donald Hoffman, who's researching on reality. They claim that the entire universe is nothing but a simulation. So are we saying the same thing? Are you also saying that what we are currently living in a simulated world, which is quantum mechanical research and such? I mean, is that what you are also saying?
This is a slightly different view. I mean, when you say that whether you are living in a real world or in a virtual world, or maybe some people, like what you're trying to point out, some people say that the world in which we live, maybe nature is doing some simulation. So that is slightly different view compared to what Niels Bohr was trying to say. So this view is to do with the fact that whether we can distinguish the computational world from a real world. Okay, so that is the reason why some people believe that maybe ultimately we will not be able to distinguish from a simulation from a real world, and those people believe that the whole world that we live in, maybe it is a simulated world. Who knows? But yeah. So, but this view is not exactly what Niels Bohr was trying to point out.
Right. So I have been vested in virtual reality since 2015, and the ones who are really creating the cutting edge of virtual reality, their intention is to simulate the physical world. Now they are tying up with neuroscientists, and I have had the privilege of having conversations with neuroscientists who are working on downloading or scanning the entire structural and functional capabilities of an entire human brain and mapping that onto a computer. Elon Musk is doing the same thing with Neuralink, because all of our senses, of all of our five senses, they rise because a sight, sound, touch, smell, taste comes out because of the way our neurons fire. And there are these neuroscientists who are trying to copy the structural and functional data of the brain and map it onto a computer. In fact, they have also mapped a C. elegans worm. A C. elegans worm is a worm which has got somewhere around 302 neurons only. So they mapped the entire 302 neurons of the C. elegans worm, and they uploaded onto a computer, a Lego computer, and the Lego computer started behaving exactly like the C. elegans, real life C. elegans worm. So in theory, if and when we are able to completely map our entire structure or cognitive structure and upload it onto a computer, then maybe possibly we'll be able to create a virtual world where it could be a simulated world. Anyway, that's a little this thing. So
yeah. That is the hope, but yeah, man, still long way to go.
Quite a long way to go. But then there are quite a lot of scientists who are working towards that. We're working on brain-computer interface with that goal in mind. Would you like to talk about your current research and works? Can you share some of your works that has gone from research to being implemented?
So I've been working in this field almost for more than 30 years now, and some of my early results in this area in quantum information are trying to figure out what are the key differences between classical information and quantum information, and trying to propose some new quantum communication protocol, and trying to understand deeply the meaning of quantum information, and and also trying to use entanglement in quantum algorithm or quantum computing, especially trying to understand what is the role of entanglement, because you see quantum computing has been there for more than 30 years now, but what really gives power or efficiency to quantum computing devices, it is still a lot of research still going on, and in early days people thought maybe you need quantum superposition, quantum entanglement, but this question is still going on. So we have been trying to also figure out uh, where you need really this entanglement, or do without an entanglement and so on. This kind of things we are trying to explore. Uh, and in, so so currently we have been diversifying to apply these quantum information tools, in quantum thermodynamics, which may be useful in building like more efficient energy storage device, which are called quantum batteries and so on, and quantum thermal machines, quantum heat engines and so on. So a lot of things are happening.
Right. So what are your views on India's quantum computing industry? Because there are a few leaders in the space who are vested and are trying to build quantum computers. In fact, I had the privilege of interviewing Dr. Vijay Raghavan from TIFR and understanding what he's building, and he's doing some fantastic work. What are the innovators or innovations here in India when it comes to quantum research which has caught your attention?
When you talk about experimental investigations, we are still a little behind. But having said that, 5 to 10 years, there are some experimental groups, as you pointed out, Professor Raghavan. His group has been involved in doing superconducting qubit, and I came to know that also in IISc they are also starting to set up a lab with superconducting qubit and so on. In IIT Pune, they are trying to scale up with NMR quantum computing devices. So there is a lot of effort going on in that direction in IIT Pune. And yeah, there is also INTROP group working in IIT Pune. And talking about quantum communication, we have one of the most leading group in RRI, which is led by Professor Basisina. And they're trying to also have collaboration with ISRO and they have a very long objective, trying to have this kind of ground to satellite quantum communication in future. But that group is one of the leading group in quantum communication now. So, and I have been also collaborating with Professor Basisina and RRI. So yeah, so a lot of hope.
When we have like a working quantum computer, do you think are the applications that's gonna come out of a working quantum computer?
Full-fledged working computer may take, I don't know, maybe another 10 years or so. But at least proof of principle quantum computers are already available, and maybe in next 5 years something may happen, and maybe we will be able to use those quantum computers to do several things like in finance sector, maybe in defense sector also, or maybe we can use in design of new drug, or maybe design of new material, a lot of applications there. So it is up to your imagination, And
Would quantum computation play a role in boosting or accelerating artificial intelligence? Because there are a bunch of people who are experimenting with artificial intelligence, and there are people who are working on artificial general intelligence. Do you think there's a link over there? And would
yeah, certainly. I mean, there is already the direction which has been quite exciting is that is called quantum artificial intelligence. So a lot of groups are actually taking deep interest in this, trying to combine quantum computing in artificial intelligence, and this new area is emerging now. So I think it will play a major role.
Right. So China recently, I think, announced that they have built a quantum computer, which is they claim, at least they claim, the news claims that it's the world's fastest quantum computer. They say that it's 1,000,000 times faster than the Google Sycamore quantum computer. Would you like to share some views on that?
China's claim and Google's claim, and they are not really universal quantum computer. That means you cannot use those devices
Right.
to do any task. Okay, so
Right.
they are designed only to test that particular to implement that particular task. It is not a full purpose of, quantum computer which you can use for anything. So, but again, whatever they have demonstrated, that is really remarkable. And that really shows that the theoretical idea which has been there for more than 30 years is actually not just something out of reach. It is, you can actually test it. So it tests your prediction, and that is satisfying. That is really something exciting.
Right.
But
Yeah.
nevertheless, you go beyond that. Yeah.
Right, yeah, and I think quantum computing would be a complete paradigm shift. When we have a working quantum computer, it can create huge transformation, across drug discovery and so many other applications. And that's the reason I think some of the nations around the world like US, China, Canada are deeply invested in quantum computing. And in fact, the National Mission on Quantum Technologies and Application had allocated around 8,000 crore rupees to be used over a period of 5 years. Where does that stand at this point in time? And has the funds been allocated, distributed properly? What are your views on that?
No, that is still not approved. I think it's still. I think final approval is still pending with maybe minister or maybe finance minister. So I don't know that part. But what I know is before this national mission was announced, there was already something called Quantum Enabled Science and Technology Quest that was initiated in 2017. And that was started by DST. And here at HRI, we had a brainstorming session to formalize that program. And that program is kind of phase 1 of this national mission. National mission is kind of phase 2, and this Quest program is kind of phase 1 of that mission. And in that Quest program, there are about 50 PIs who are involved in research, and for that DST has allocated something like I don't remember exact number, but something like 400 crore for next 3 to 5 years, so that is already approved, and many PIs have got the first allocation of the money, and that is going very well actually. India has already taken a step, the first step, in a national, in a consolidated way, and the next mission, it will take some time, but it will happen slowly. Yeah.
I think we taking the right steps. It's just that when you said that the 8,000 crores is still not allocated, still, I believe that there needs to be an urgency which needs to be showed by the government, because these technologies will redefine a nation. And that's the reason I think USA, China, Canada investing so heavily in technology, specifically in quantum computing and artificial intelligence, because when they mature, the benefits of those technology is going to be completely humongous. So I hope we have somebody like you representing the national quantum mission, because we need people who are vested in the space rather than government bureaucrats. Recently, the Ministry of State for Electronics and Information Technology had launched something called as QSIM, which is a quantum computing simulator toolkit. Would you like to explain what it is and how it is going to help accelerate quantum computing?
Programs supported by MEITY and also by other funding agency, and this IISc, Indian Institute of Science Group, I think they developed this essentially to simulate quantum computing programs on a classical computer, because you have to just simulate it, not real quantum computer that we don't have anyway. So the existing classical computer, what can you do? So that motivation, they try to develop the simulation toolkit, and then this is not really going to help development of quantum computing, but it will at least test the basic ideas with the existing classical computer. You can simulate your circuit, you can simulate your program, and so on. So it is useful, but but I don't think this will really help in building quantum computer. That is a slightly different issue.
What would you have done to accelerate the quantum computing mission or technology here in India?
I mean, ideally, it will be desirable, most desirable to have some kind of national institute or maybe international institute of quantum information technology at one place, okay, and you invite all the leading people from India, okay, who are doing theory, doing experiment, and maybe everyone comes and they try to set up their lab, and they work in a collaborative manner, and then you hire students and postdocs and try to hire young minds and try to develop a vibrant atmosphere, and then that is where I think one should proceed. But it is not really, I mean, not that easy what I say.
What do you think is blocking the growth of quantum computation here in India? Because software, we are great. Is it the hardware which is the problem?
Yeah, certainly. I mean, hardware and creating infrastructure for developing hardware, new hardware, and so on, having high-end equipment and laboratory setup. These are key things we need to focus on, and this is really missing. And also, I think partly to do with not having real vision. I mean, so for example, I've been working in this field for more than 30 years, and I've been telling to many senior people, when I was young, I've been telling that we should focus on this area, I should, encourage more researchers in this. But at that time, nobody paid any attention to, if this could have been started 20 years back, now
exactly.
India could have been at the same par with China or maybe USA, So that is really sad part of this story. I mean, but what to do? I mean, but yeah, it's not still late. I mean, if India already taken interest, so hopefully in next 5 years or maybe next 5-10 years something will happen. And another thing I can tell you about accelerating quantum technology in India. So recently we also set up something called Quantum Ecosystem and Technology Council of India. So this is a private kind of non-profit organization we set up. Myself and Reena Yadav, she left Microsoft just to devote her time in this, and another person, Ramesh, from Hyderabad. So we try to set up this council, QETCI, and one of the major goal of this organization is actually to accelerate quantum technology in India. So we trying to, we hope to be kind of, think tank for the government and academia and industry, and we would like to also set up collaboration and mutual partnership with industry people and academia and maybe government agency and so on. So we're trying to, only just 6 months back we started this, and already we have on board people from Amazon and from Microsoft, and also we are talking with IBM and many companies that actually they are now full members. And so that is at least from our side we're trying to do something.
It's with people with foresight who build the world. I mean, and we need to nurture and nudge people such as yourself who have foresight and support their vision. And because
you will be surprised. I was working almost for 10 years in a very hostile and very totally disastrous atmosphere kind of thing. I have no support, no moral encouragement, nothing. On the contrary, they were trying to discourage me. They're trying to stop my promotion. They're trying to do all kind of harm to me. That kind of thing was happening.
Wow, this is so sad. There in China, the one who's leading their quantum computing is Jian Wei Pan, and they are supporting him with everything. There's a $10 billion fund, and that's the reason they're leading, because they understand, they have a vision, they have a foresight, and it's only because the world is growing so fast. All of these technologies are growing exponentially, and if we leverage these technologies, it will give a nation an undue advantage. It will give them an advantage, and I guess that's the reason America, China, Canada, everybody is working towards building a quantum computer, and we still pretty much slow.
India has taken interest, at least if not 30 years back, at least if 10, 20 years back, now things would have been completely different, which is very unfortunate. I mean, at that time, they thought that what I'm doing is useless. This is not the agenda of national importance. This is not, India should not do research in this. That kind of statement they're making.
I hope India wakes up. I hope the people of India wake up, because at least from the COVID, one thing is very, very clear, that digital is the way forward. And the ones who have the access of technology will be able to create better life. And artificial intelligence, quantum computing are the two technologies which I think will open up huge economical benefits once we have a working quantum computer. So I hope the people of India, I hope the government of India supports this movement. I have a question from my listener. His name is Shivam Yadav. He asked, how much time will India take to build a 50 or more than 50 qubit quantum computer? And what is the current indigenous capability in the field of quantum computing?
Yeah, so currently we have several labs working towards quantum computing. As you know, one lab is in TIFR, and also in IIT Pune, and also in IISc Bangalore. Also in IIT Mohali, they have also a setup for NMR quantum computing. Yeah, in IIT Calcutta, they are trying to also set up this NV Center quantum computing. So there are several groups now. Coming to the question that how many years it might take to reach 50 qubit. Like Professor Vijayaraghavan lab, they have about 3 qubit now. So I think I'm hopeful that maybe in next 5 years, technology may be mature in India. So that is, quite optimistic. So I'm hopeful that something will happen.
India, the problem is that we keep on complaining that how come we Indians India does not have a single global company, and the reason is because we shy away from investing into future tech such as quantum computing and artificial intelligence. We go for the low hanging fruit. And I hope that there's a change of stance from the government, the change of stance from the venture capital, and we go and support.
If some private people try to invest hugely, like what IBM is doing, we can also do in India. I mean, this is possible. I mean, but we don't have that kind of funding currently. So we really need the support from private parties.
If somebody who wants to understand quantum physics, quantum mechanics, and he wants to explore it as a career opportunity, where does he start from?
Yeah, I mean, you need a basic course in quantum mechanics. So whatever you learn in your MSc, in addition to that, you have to read this very classic textbook on quantum computing by Nielsen and Chuang. That is one of the Bible, most referred book in this field. And there are several institutes in India now. They offer a course in quantum computing. Like in HRI, we have been offering course in quantum computing for the last 10 years or so. And now there are many other institutes, they have started also regular course in quantum computing. So one can attend those courses. And then one can go for PhD either in India or abroad. So these are the steps one should take.
Thank you. It was a complete pleasure and honor to converse with you. And I wish you the very best. And I hope that you play a major role in shaping or laying the groundwork of India's quantum computing industry. Would you like to paint a picture of what once we have a working quantum computer, what it will be able to do? Because there are these companies who are working on, like for example, IBM was claiming just the end of the year that they have built a 127 qubit quantum Eagle processor. And their roadmap is that they're saying that by 2023 they're looking at 1,000 qubit quantum computer. Then there is a company called as Seeks, who are saying that they're working on 1 million qubit quantum computer, an application specific enterprise ready quantum computer. So there are these lot of these lose information. There is China who's claiming that they have a quantum computer which is million times faster than what Google Sycamore has done. When this actually all comes together, paint a picture from your end what the world will look like. How will the world get transformed? Inspire those people who are listening that what quantum computing, when it's workable, what it will actually be able to do.
When it actually comes to market or actually comes to your desktop, your table, in your office, the world will completely change. It will starting from communication to secure banking to secure financing, and everything will completely change. So quantum information has very unique feature, unique property that nobody can make a copy of quantum information. That means if you store information in quantum computer, except you, nobody else in the universe can make a copy. So it is fully secure. The whole issue of piracy will disappear. And there is also a proposal to design quantum money, using quantum information. So if you design quantum money and store in quantum computer, so you can connect two different quantum computers through quantum entanglement, and you can do transaction of quantum money, which is full secure. So nobody can hack it, nobody can copy it, nobody can do anything with your quantum money. So a lot of things will happen. So it will completely change the whole world. So there is no doubt about that.
Thank you. Keep on doing what you're doing. Wish you the very best. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye-bye. Thank you, Professor.
Thank you very much.